Hello everyone, this is Riccardo Bancone, and in this tutorial I'm going to show you how to recreate part of the Shrinkwrap modifier functionality with geometry nodes. In this tutorial I'm using Blender 3.1 Alpha, but I think what I will show you in the tutorial will be okay also in the stable 3.0 release. Anyways, let's start. Okay, now I have a little setup with my monkey, Suzanne, which will be the target of the Shrinkwrap modifier. I have this plane with the subdivision surface just to have a little bit more definition on the plane that I want to shrink wrap on the Suzanne. Then I have the Shrinkwrap in project mode and another subdivision to smooth the surface after it's projected on the surface. Now in this tutorial I'm going to recreate a particular configuration of the Shrinkwrap, not all the functionalities, just as an example. So the configuration I'm going to replicate is the wrap method project with positive and face cal front. And I also want to implement the offset functionality. So let's see what the Shrinkwrap does. As you can see, the plane with the modifier is projected on the Suzanne target object, and it has an offset that I can dial in to adjust the surface. Now I've already recreated the modifier tree on another object. As you can see, I've parented the plane with the modifier, with the geometry nodes modifier, applied it to the plane modifier to check if they match. So if I input the same where is it? The same offset, like 0.1 and minus 0.1, I have to invert the value, but it's the same. As you can see, the result of the plane modifier, which is the yellow one, and the green one, which is the Shrinkwrap implemented with geometry nodes, the result is the same. So I'm going to start by scratch. I will recreate this node tree on another plane here. Alt P, just let me unparent it and hide the rest. So I have this plane and I want to replicate the same behavior of the modifier with this. So let's create a new geometry nodes tree. And I'm going to add, first of all, I'm going to subdivide it a couple of times. So let's add a subdivision surface node with a couple of subdivision. Let me check the reference plane. I have 3 subdivisions. So let's replicate that with the nodes. Where is it? Oh, sorry, this is the already done. This is the one I want. Let me pin the node editor, and so I want 3 subdivision levels. Now what I want to do is to somehow project this point on the monkey. So the node I need is the Raycast node, and the Raycast node wants a target geometry on which project rays from the source geometry, which is the plane in my case. So I'm going to drag Suzanne from the outliner into the node editor. So I have the object info node automatically created for me. I set relative and I plug the geometry output to the target geometry of the Raycast node. Now what do I do with this? I want the rays to be shot from the vertices of my geometry in a particular direction, which is the normal direction, because by default I have this ray direction that tells Blender to cast rays from the points of the plane in this particular direction, which is from a vertical direction, negative vertical in this case. So I want the rays to be shot from the normal, so I have to create a normal input. Here it is, and I plug it into the ray direction. Now the rays are cast from the point to the normal. I mean, the direction will be the normal of the plane, the positive normals, which is what I want. But still, nothing is happening because I now need to use to calculate and use these outputs to displace the geometry. So how do you do that? I need a set position node, and I put it here. So the set position is going to alter the position of the vertices based on this field input, and I want it to be connected to the hit position of the nodes. So now what's going on now is I don't see anything because let me check. Now basically I'm not selecting anything. Every ray is going to be projected on the hit position, and in this case, no. Look at this. The rays that hit the surface from the inside gets displaced. The vertices, sorry. But the vertices that are not hitting anything are just going collapse to zero. So that's where the selection input comes handy, because I don't want every vertex to be displaced. I just want the vertices that hit successfully the target object to be displaced. So his hit is what does the job. So I just take this field and connect it to the selection. Much better. Now, as you can see, these vertices are shooting rays and they are not hitting the surface, thus they are not being displaced. They are not being affected by the set position node, but just the ones that are that successfully hit the surface are displacing. But right now this is not completely the result that I want, because if I move here, even from this direction, even if the plane is behind the monkey's head, the vertices are still being displaced. And so I want the vertices to be displaced only if they hit the surface from the inside, but not from the outside, like is happening here. And to do that, I have to use a particular vector operation, which is called the dot product. The dot product just take two vectors and performs an operation. I'm not going to explain what exactly it does, but bear in mind that if the two vectors are face in the same direction, the dot product outputs a positive number. If they they point to opposite direction, I mean they're not like if two normals are opposite, for example, the dot product outputs a negative number. So I'm just interested in the sign of the dot product between the hit normal and the surface normal. So what I'm going to do is to add a math node, vector math node, and I'm selecting dot product, and I want to perform the operation between the normal of the target the hit normal between the hit normal and the normal on the surface. So, and plus I want to check if the result is positive or negative. So to do that, I have to create a compare node. Bear in mind that if you are using the 3.0, there is the float compare, and in the 3.1 version you have the general compare node, which lets you choose what type of operands are you operating on. And in my case, it's a float number, because the dot product output a float value, float number. So I want to check if the dot product is greater than 0. So I just connect the dot product, and the other output is 0, and the result will give me false if it's greater than 0, and if it will output true if it's greater than 0, otherwise it will output false. So I want to combine this result with the selection, so I need a Boolean math operation, and I want it to be, this should be true, and hit should be true as well. So AND operation is what I need, and I'll connect it to the selection of the set position. So as you can see, now it works. Look what happens if I mute this node. Sorry, this one actually. Only this condition is, as you can see, is taken into account. So only if you can see it sticks, the plane sticks to the monkey's head, even if the normals are hitting the external surface of the vertices, the rays are hitting the external surface of the monkey, or from the inside or from the outside. Let's put it like that. If I activate the node only from the inside, this is working, and this is the behavior that I want. So the first part is done. Now I want to implement the offset feature. So I can use this socket of the set position node, because this socket just sets the absolute position on the vertices. This adds some value to the position of the projected vertices. So in this case, I can, for example, offset on the vertical positive axis just by moving the vertices, but I want a field to be connected this here. So the value that I want is the normal captured at the moment of projection, the original normal, because I kind of observed how the Shrinkwrap modifier works, and I kind of reverse engineered it, and I can see that, look at this, if I activate back the plane with the modifier, this offset is moved along the original normal of the target. Okay, so I want to replicate that. So I will use the capture attribute, which stores the value of a particular attribute on a geometry at the moment in the point where I place the node. So in this case, I want the normal just after the subdivision. So I place the capture attribute here. I want the normal, so I want the vector value. And now I specify what attribute I want to capture in the node by inputting it into the field socket. So I want the normal. Here it is. And then I output the capture attribute here, and I plug it in the offset. But of course, the normal is normalized. I want to, modulate the intensity of the displacement, and to do that, I need a vector scale node. So actually, I want a vector math node set on the scale operation. And in this way, I can easily adjust the offset. If I want it to behave just like the modifier, I have to plug a minus, but I actually prefer to keep it positive because I don't know, it looks intuitive, because if I plug a positive value, it just displaces the geometry outwards, so it makes sense to me. And finally, let's just add the another subdivision surface. That's just like I did on the original one with the modifiers. And let me check. It looks good. Now the final step is to see if we are getting the exact same result. So to do that, I just reactivate the original plane modifier. Of course, I have the same mesh. Now I want to copy the position, the location, and copy the rotation, so they stay in the exact same place. And actually, I want to parent the geometry node plane to the modifier plane. Object keeps offset. So if I want this to be parented to this. Control P, keep transform. And now if I move the plane modifier, the geometry node, the plane with the geometry nodes will move along. Let's just input the same value from the displacement, so I can easily exactly compare if they are performing this exact same operation. Let's plug in like 0.1, and on the modifier as well. Where is it? Plane modifier. Let me go to the modifier tab, and it's already 0.1. There's a slight difference. I'm not really sure what it is, but we have 3 subdivisions before with use limit surface off, and then we have another one with just 1 subdivision. I don't know what exactly this minimal difference is, but I'm pretty satisfied with that, to be honest. They behave just about the same, as you can see. Nice. So that's it. That's how you recreate a Shrinkwrap modifier with project mode in geometry nodes fields in Blender 3.1. I hope you enjoyed this tutorial. Let me know if you have some ideas on how to improve the technique. If I did something that maybe is wrong to you, I'm open to suggestion. I'm learning myself right now to use fields which I find to be very, very cool, very kind of intuitive once you get how they work. I think they are great. Let me know if you have any suggestion. So bye.